All right. So welcome back, everybody, to JETSON AI Lab. Today is September 17th. Thank you all for joining us back. We have lots of presenters and new updates to share today. Johnny has been busy building all these new packages. Last time it was the Nerf stack. This time it's JAX, which is like Google's. It's like machine learning, NumPy, vectorization. It seems quite nice. Some of their newer models in robotics embodiment have been using it. So we finally got that to build, and are close to get the other ones to build that we'll dive into in a bit. Catalan was going to demo us his latest Isaac Sim, Isaac Ross integration and the vision language models, which is great to see all of this stuff coming together at the same time. It was kind of too much for any one person to handle, which by this group is great. We're all kind of like going out and do different parts. Speaking of which, Chitoku got LeRobot to build, and we made a page for that on the JETSON AI Lab, which is up here. So there's like a container for this. There were some patches needed to build it. Later in the call, Chitoku can share it running on like his JETSON, but it has like these different policies built in. There's some diffusion ones, acts in there. So while we kind of got into this with the Open VLA, there are other ones that we're now going and exploring as well. Like this is kind of the main one from the diffusion policy side of things that all the other papers come from, and now got into like 3D point cloud versions of that. And Nigel from the group, sometimes he's here, and he's from NVIDIA and trains, been working on these, has been doing it in 3D and says that works a lot better. So we look at like the 3D version of this, the crossformer, that's where like the JAX comes in, and Octo is Berkeley's other model. So to be able to try those and characterize the performance, and they all have different characteristics. Like some are multitask, some have really good natural language support, different trade-offs that they have. And to be able to, these are all like very heavy websites. But yeah, we basically doing a review of the state of the art in embodiment research that everybody can just go off and do, with the goal of these like robot learning workflows that you can deploy on device or on workstation or spot instance in the cloud, depending on how big it is. And on the other side of things, Cablan's been working to integrate the vision language model stuff with Isaac Sim and preparing a sim to real demo with the Kaya robot. I think you've been using Catalan for this upcoming AI summit in India next month. So I know you wanted to share some demo of the latest stuff you've been working on. Do you want to take over the screen sharing?
Yeah.
Walk us through what you got. Your articles are great, by the way. Thank you for helping everybody with that and getting everybody up to speed on ROS. Cablan was he was having AV issues, so that does free up a bunch of time here. You're welcome to, here, I'll stop sharing and you're welcome to take over, because this is a really cool project, and it's great to see you guys getting traction in the ROS developer community for doing this. And I know there was previously one ROS connector for GPT. I think it was called like ROS GPT package or something that connected to the OpenAI endpoints and such. But otherwise, it was a few months ago that Chitoku, the others that do the JETSON AI Lab were like, hey, let's start putting more attention to getting Gen AI and this latest stuff into ROS. And about that time, you published your stuff, and it was great to see. And thank you for reaching out and getting in touch with us. We really appreciate it.
Cool.
Thank you for having us. I know there were some other projects. I don't think they took quite the same approach, so we're a little bit differentiated. I know there's like a ROS to AI, which is more of like a command line thing where you basically you just use the command line, and I think it just connects to the ROS to CLI tools. But we took a slightly different approach. We basically came up with a set of tools that uses like the ROS-Pi or RCL-Pi for ROS2 to actually pull data, to retrieve data from the ROS system. So I could maybe show you a couple of those tools, like the ROS topic list.
If you could make your font a slightly bigger, that would be great. But yes, it was like you guys were on the more agentic spectrum, and some of the stuff we've been doing is like just expose the VLM or whatnot, and they could feasibly even use each other, which is kind of cool.
True, right. We're looking at potentially collaborating with some of the other frameworks that are out there, hopefully to try to just develop some kind of community edition of this type of functionality. Of course, we made it extensible so we could do cooler things, I guess, with specific robots. I could probably show you a demo with the Spot robot, where we gave it the ability to basically gave the agent somewhat of like an interface to an Xbox controller. So it's almost like controlling it with a controller. So it could move around, it could turn, it could sit, it could stand, and things like that, as you would do with an Xbox controller. But the core agent that is up on GitHub now is primarily exposed to the ROS system through these custom tools. So we made it pretty extensible and flexible. So for instance, like with the ROS topic list, you could pass in patterns as you would like if you're grepping on the ROS topic list CLI. You could provide namespaces. You could provide blacklists, for instance, if you don't want to expose the entirety of your system to these models. And then we return these kind of structured outputs, which have been shown to perform better when you're running it through an LLM. So the response of these tool calls will be piped back into the LLM, so it could infer and kind of either summarize or give you a structured list, like maybe in a table or in Markdown and things like that. So this structured output helps with that. And there's a lot of them. I mean, there's probably a couple thousand lines of code here for the ROS1. We have similar.
Like you wanted to expose the underlings of the ROS system to the agent, not necessarily for the user to speak those commands directly, but for it to use like recursion to chain these together to like achieve more complex behaviors.
Exactly. Yeah. So one of the examples that I like to give is if you ask the agent, give me a list of topics that have publishers but no subscribers, which may indicate some kind of problem on one end or the other. Yeah. And so that's kind of like a multi-hop query that would require chaining tool usages together. Yeah.
Yes. And today you would use this in I think GPT-4. And I had gotten that recursion or multi-turn function calling to work like a few times with the local one, like the Llama 8B variants. Yeah. But they weren't, I think further tuning is required for like robotic agents. And when we first started having these meetings, one of the very initial topics was of this like controller LLM that would be tuned to like the system that you were on. And if you think of any good ideas about how to like collect those data sets of the internal agent state, that would be really useful. And it's interesting with the recent OpenAI announcements. Now everybody's very interested in these chain of thought data sets, and I read that they detect that people are trying to extract it and like block that from distilling. Yeah. So like that we're trying to find like this chain of thought generator, because otherwise, for the action models, like we just are going to collect the ROS bag and make a little pipeline that, like you go out and teleoperate and have it in sim, and it generates the ROS bag, and then that trains your policies and goes off. But this will require some like mix of human input with like event logs coming in or whatnot. It would be great to collaborate on this as like the higher level brain of the robot, or a multi-robot coordinator. That too, because it's not long before you have multiple of these, and the user really wants to be speaking to the system that like controls all of them at the same time. So that would be interesting as well.
Yeah, that's actually pretty much what we had in mind, almost spot on. The idea is that ROSA is kind of like an in situ operator, so to speak, or kind of like a, maybe a professional operator. For reference, I do ops. I'm also the integration lead on the Nicer Nebula project. I was on the EELS project, which we made the cover of Science Robotics back in March. And it was, during these experiments, we took the EELS robot up to a glacier, and it was like 30 people up there, and there were a lot of instances where we needed certain subject matter experts, and they just weren't available for whatever reason. Maybe they were out that day, or they were having fun, descending down a moulin or a crevasse, whatever it may be. But we had these.
Maybe pull up this Nebula page and show the group. I just pulled up. It's like you took a spot and loaded as much stuff onto this poor thing as it could and took it up to the Arctic Circle or whatever. So yeah, like walk us through what you but a lot of us have been focused more on the AI side for a bit of time and vision, but of now that this stuff is getting real with the robot, like we're excited to get back hands on. What all is going on there? Like you add to it? Is there any JETSONs on there? I think I see a RealSense D345, or I forget there.
Yeah, it's a 455.
Okay, the mini one.
Yeah, we got a Velodyne. We have several of those RealSense depth cameras. We do have an Orin on board. We have 2 Orins on 2 of these now.
Okay.
And we're using those for VLM type work. I just got ROSA running with Llama 3.1 on an Orin. So we no longer have to rely on like API for inference.
Yeah. That is great. So walk us through how, there's a lot to dig into here. This is so awesome that you've already been able to accomplish this, given like the complexities of Gen AI at the edge and all that software and everything. What like VLM are you using, and how are you running your Llama model? Walk us through the process that you went through to take it from OpenAI endpoint to running locally, and other problems that you face that we could make easier.
Sure. So the OpenAI thing started out as like a pilot. We were trying to get kind of institutional support for these Gen AI systems. And I was deeply embedded in robotics as is, so I decided to go that route. I don't know why, it just kind of occurred to me that this was, ROSA, this type of agent framework to help with robot development and operations was just the right way to go. So I took advantage of the fact that we had these very big, powerful models like GPT-4, and basically we didn't have to worry too much about the cost. But also it allowed us to really stretch what we believed was possible. Using the larger models was great, because if it could be done there's a good chance you could distill that later and get it to work on smaller models.
Yeah, you want to find out if it's possible first, and a lot of robots are still doing that. And I've heard even some like the advanced agents they run through. It can be like it was like 50 cents a second or something for the number of queries they were doing through. But you got to know if it's like possible to do. And another thing you could do, because I know you brought up that obviously Llama 3.8b does not have the same function calling capability or chaining that GPT-4 does, and it is more limited, but hopefully it could be tuned to be more adept in this specific type of scenario. Should we be able to collect those like chain of thought labels?
Shehryar, I see you have your hand up.
Yeah, I also wanted to give a bit background just and ask about what's happening like underneath on the ROS side. Maybe you can set up, Rob, the demo video for the spot one. We can show the group here.
Yes.
So Nebula is just our autonomy stack written in ROS. It has all the capabilities that you would think about from a traditional stack: perception, localization, mapping, multi-agent teaming. But the issue that, again, Rob mentioned was that we had these multiple robots, this system written in ROS running. But whenever we went to the field deployment and the team changed, we lost some subject matter experts. And in the end, the operator had this big gap that, hey, how can I command this robot doing? So again, we are not coming back to your point of action. The actions specifically are not generated using LLMs or anything. The actions are still going through the traditional stack. It's just, it makes it much easier. For example, one-to-N robots teaming, like one operator to N robots. And we are very interested in like hosting these locally because eventually if you send them somewhere remote, like on the moon, we won't have the internet connection. So it's very important to have them locally hosted. And that's why Rob is pushing these days for the smaller models running on board. And hopefully we can get an hour into the moon one day. So
yeah, there's a Pittsburgh company, Astrobotic, that I worked with for years that does like lunar. You would be surprised. There's actually plenty of Jetsons in space already. I would tell them like void the warranty, but like you can do what you want with Jetsons. You know, we won't stop anybody. But yes, you could very well have another end-to-end policy below this as like your local planner or whatnot. The system can almost be like decoupled, which I think really aids in people's like adoption of this. Very few people are just like, okay, let's like replace the whole thing. Even myself, you need like safety layers and such underneath of it. And so understanding those like integration points of how do these agents like speak together, or are those constraints like limiting the flow of information in any way? Is it better to have a like omnimodal state machine like model that you train where it can have variable types of inputs and, you know, set outputs, kind of like Florence 2, like vision processor that, you know, maybe it takes in input text from the user or latest image and like outputs other actions into the system that or other things depending on what it is. Then it will retain like all the information world state. So, and I assume you're using like the VLMs for not in the same model, but can be like connected together with this for other like scene recognition or understanding.
Yeah, that's exactly right. Actually, if you don't mind, I could play this video. It's 3 minutes long, and it will show both the raw side of things, some command and control, and also some scene scene understanding. All of it is using GPT-4o, so it's a single model, and it can do all those things. It's really cool. Unfortunately, we don't have kind of an analogous local model that could do all of those things.
We can talk about that next. But even so, it's cool to
Cool. Let me know if you could hear the sound all right. We gave it speech.
Hey, Spot, can you stand up?
Can you hear that okay?
Can you stand up?
Yep. Okay. Thank you.
I have stood up and am ready for action.
Can you move forward about 2 meters?
So we're giving it the RGB plus depth from the RealSense. And that will come into play shortly. This is in the Mars yard here at JPL, by the way, as you might be able to
I've
tell
moved
from that
forward
image.
2 meters. What's next?
Can you turn to your left about 60 degrees?
We're using our lamp stack for localization, so it, you know, it could do that 60-degree turn.
Yeah, I'm trying to ascertain like which ROS commands does it actually issue from it.
Describe what.
Sorry, I'll pause right there. Yeah, so you could effectively think of, so basically what I did to pull this off was I listened to the ROS topic that was publishing all of the Xbox controller commands, and then I just mimicked that in custom tools. So there's a move tool that takes like 3 different like roll, pitch, yaw basically, and then there's a turn in place command that takes like a degrees argument. And then I gave it some conversion tools, so it could convert degrees to radians and vice versa. And basically, what you just saw was when I asked it to stand, it basically pressed the A button on the Xbox controller. When I asked it to move forward, it basically controlled the joystick. When I asked it to turn, it again controlled the joystick with certain buttons that you have to press or keep held down in order for it to continue moving. Along the way, it did some calculations, like it converted degrees to radians and so on.
Have you recorded these calls? Yeah, it occurs to me that's just what you need to do is like record this running with GPT-4 as the agent, and then just fine tune the Llama 3 one on it so that it makes like the same correct function calls for that. It is like the trainer model.
Right. Yeah, we were looking at like instructor student paradigms to do that. I just got Llama 3.18e working. There was the default context window for that is like 2K, and ROSA needs at least 4K tokens just to get all the prompts in with all the tools and descriptions and things like that.
That's another thing about like so I mentioned these like more like bespoke vision hybrid VIT processors earlier, and one potential benefit of the think of it as like the bit packed version of, because JSON is like very verbose and causes lots of extra tokens. Like every digit and separator is a token, and it not only eats up your context window, but like that's the speed at which the agent processes, and in the edge, like every token per second matters. So how did you currently deploy Llama 3.1 with the function calling? Was it with like Ollama, perhaps?
Yeah, it was Ollama using Llama 3.1, and it's quite simple. If you have it running on the same device, you literally just have to tell it what model to use. You instantiate the chat Ollama model in LangChain. This is all using LangChain, by the way.
Okay.
So it's a very simple. It's probably even easier to use Ollama than it is to use GPT-4 because we're using Azure, so there's all kinds of APIM subscription keys and things like that for Azure. Ollama's a lot easier, so it's a pretty much drop in place replacement.
It's great, yeah. We have like tutorials on the JETSON AI Lab page for that. For people getting started with Gen AI, we recommend like get into Ollama and Llama Index and those the easy to use ones. And then on the other side, we have like the higher end quantization libraries with like flash attention and Cutlass, and they get almost like twice the performance, but are a little harder to use. Although the one we use predominantly, MLC, that can spin up a OpenAI compatible server that I believe has similar signature to Ollama, or LangChain has like OpenAI connector, obviously, that you would point it to instead. It's very similar thing to the Ollama server.
MLC sounds interesting.
They're CMU. I know the guy, Takani Chen. They're great. Then it's really cool because they're into like supporting all these different edge devices, and we have benchmarks on the page. Like that's how we get almost 50 tokens a second on Llama. Like how many tokens a second are you getting out of it?
Yeah, not 50. Maybe like 4 or 5.
Yeah. Okay, on 8B it's like 42 tokens a second is what you can. And
that's pretty good.
if you could dig into the JETSON AI Lab, which I realize has grown to become, a bit large given all the awesome stuff in Gen AI that seems to all be like coming together, and this ROSA agent can be the one that like ties it. Yeah, it's an echo quick, but yeah, I think that would be awesome way that we could work together going forward. We could help you with the optimization if needed, because I also tell people like if you're just doing tech stuff, it's cool to like you can stick with a llama. It's easy. If you're doing like real-time VLM, we have all like super optimized for that and mini VLMs that can do like up to 7.5 frames per second on AGX over. Are you using NX form factor or AGX?
I believe it's the AGX.
Yeah.
Nice.
Is that right, Shehryar?
Okay. Yeah. So look
AGX
into like
4 gigabytes.
Vila 1.53B mini VLM, and that is like the fastest one that we have currently.
That's what,
Yeah.
I got a
Alex, go ahead,
question.
man.
Yeah, being like, I need to ask this. This is a Boston robotics robot, correct? What is
yeah, the core robot. Yes.
Yeah. Because the other day I was watching this demo of this other robot by Unit 3, and this guy told me that he had to jailbreak that particular robot because Unit 3 does not allow you to make any modifications or something. Is this the case with this particular model as well? Like it can be jailbreaked and you have to like, I don't know, do some stuff in the firmware in order to be able to do other stuff that is not from the manual?
No, we just use the API that is so the robot is as it is. You see the body, but the black box and all the sensing that you see is all done by JPL. So there's the LiDAR, the IMU on top, the thermal camera, the RGBD camera. There's an Intel NUC inside in the black box. There is also a JETSON 8GX, a 64 gigabyte model in there. Then we have our own comms networks on top. So as it can move around, it can actually lay down comms. So it's like a backbone. So if, for example, if we're going inside a cave or something, because hopefully one day we will find life there in a cave somewhere. And the only thing that we send is just either the velocity command or the waypoint that is through the API. So we don't need to jailbreak or void the warranty, as they say. So it's all like, yeah. I also wanted to point out, Justin, where like ROS interaction is happening. So like Rob gave the command and that he moved this much. And if you see that it is tracking the yaw and the position, and that it is taking the actual our localization stack. I also posted, it's also open source. I also posted the link in the chat. It's called LAMP. So it's taking that as a feedback because it's metrically accurate at centimeter scale. So it does the LLM just needs to give a high level command that I need to move this much and then just subscribe to the odometry or the positioning coming out from it to understand that how much it has moved. So you can think about it as like not a complete feedback controller that is running in real time, but a feedback going back into the LLM.
Yeah.
So just wanted to point that out as well.
Yeah, it's one of the common ones that get discussed in like SLAM, current
exactly
widely used SLAM algorithms and stuff like that. And it can be whatever waypoint navigator or just from GPS even that goes from that. And no, I think this is great. And because you guys have been working on like the higher level stuff, and we've been focused more. Although we got like good support for like the function calling, you like go through the site and look at our videos that like show VLM and then this mini function calling that was with Llama 8B as well, and hooked together, and it's like triggering alerts based off the VLM and more on the IVA side. And then things kind of shifted into high gear with these like embodiment models and all the research coming out in there. So now we're looking at like the motion control and behavioral cloning, then getting ready to like integrate that all together. So it would be wonderful to collaborate all together as a group if that's something you're interested in doing.
Absolutely.
Yeah, very much so.
Great. Now, did you have any follow-up questions there? I saw your hand go back up for a second. No, you good? Okay.
I'm good.
So if you haven't already, you can try the mini Vila and see how that does. But otherwise, think about starting to have to tune this or how you collect the agent data sets for it. And I guess latency is a driving factor in all of this, which is really why it was about last summer we started, before there really was a llama or that took off. And it was like llama C++ is what everybody was using, and was encountering performance issues with that on like larger context windows. And it turned out to be like long pre-fill time. And then like got into this micro benchmarking thing of like every quantization API out there, including like XLlama and MLC and all these other ones. JETSON will be getting TensorRT LLM support supposed to be like later next month around the next Jetpack release. So that'll be available as well.
Nice.
To like take advantage of all of this. But like streaming VLA is the same architecture. So right now we're just trying to build up the best support for like deploying all that and the workflows to go off and fine tune it so we can go out there and show it. But yeah, I would love to have ROSA be like the overarching system that controls one or like multiple of these. And I don't know if we can brainstorm, like you just run it in GPT-4 mode for a while and collect that all running while it's like distilling the local one in the background. Otherwise, you would have to hand annotate all that agent intermediate states, I suppose. So, another thing, do you have any plans to expose higher level ROS constructs in like your tools? It strikes me as like you were having difficulty migrating to just out of the box Llama 3 function calling, and probably because all those tools are too low level, and it does not do the like recursion out of the box super well.
Actually, I'd say the majority of the ROS tools that it has access to are pretty high level. They're the type of things that you would want to access when you're trying to troubleshoot something or debug.
Or I mean, in terms like this, like more like a command, like turn left, turn right, as opposed to like set ROS L topic to 0.5. You know, like right. If it's having trouble, you need to raise the level of abstraction that it has access to and limit the number of function definitions in the context. And we discussed on this meeting before, because when the group first started, we were running into like Home Assistant integration and getting all this stuff with that, so we could like talk to the Home Assistant IO project and did a lot of function calling stuff there. And that was a similar setup where like they can have like thousands of functions available based on the setup of like the Home Assistant and all the devices in there, and essentially have to either make higher level abstractions or use RAG on it and selectively define which ones you expose, which requires an agent, which requires a model that would tune to have functions defined mid chat or mid context, which the Nemotron one is. And like we haven't even really gotten into that. Probably won't have the time on this call, but that's a mini SLM that you also might want to consider targeting for this. It's a 4B model, and it's distilled from like the Nemo 340B, or might be 3 or 4B. It's hard to remember them all now. Forgive me, but it's like state of the art distillation from 340B and 8B and all of that down into like an SLM that has function calling and RAG tuned capabilities in it. So you can try doing, like, have you done LoRa's or fine tunes before on Llama or other VLMs or things like that?
Yeah, we've given we've tried some fine tuning, not for robotics, but my group is the AI and analytics group, and we basically are doing all sorts of LLM work. So we did do some fine tuning for other applications. Okay. I'm sure it'll be relatively similar. Like, I mean, the cool thing about this is, you know, we have access to all these traces. that show exactly
Yes,
what
okay.
the
Yeah, that's
bigger
it.
models we're kind of thinking and doing, right? So
Yes. Yeah, that's what the data set is essentially. So yeah, and at that point it's all about getting the formatting of like it expects multi-turn Q&A chat, and how to
right.
or accurately reflect that or specialize it. It doesn't necessarily need to be JSON. Like you could like bitpack it into some other more specialized condensed format, and all of this is like iterative. Okay, you do one small thing at a time and see what like works, and learn that with the VLA project. So okay, great. We'll keep in touch and have to like keep collaborating. Please feel free to come back regularly and stay involved in these discussions, and would love to not only help you with the optimizations, but like collaborate to use the ROSA agent as like the higher level planner and mission control for the robot, while we're still doing all the lower level vision to action stuff.
Yeah, that'd be great. Thanks for the offer. And this meeting is great. Sorry I didn't hear about it sooner, because I would have been here.
Oh yeah,
So,
we can
yeah.
we can publish some paper with like everybody in like the group on it. And have like 80 people.
That'd be awesome.
Okay, well, thank you, and thank you for coming and showing us. It's awesome that like you like doing this. It has everything on it, all the bells and whistles. It like checks everything box, and like you actually went out and did it. So that's amazing. Thanks for coming and being willing to work with us on it. That's great.
And I
Thank
think,
you.
Justin, just from my side, we are also like hoping, and maybe the question to the whole group is like, if you guys think of some cool demos to demonstrate the capabilities, we have it running. So if anyone has an idea like, hey, why don't you do this? Just be free to reach out, and maybe that goes into the paper or a set of videos that go along with the paper. So we'll be happy to collaborate on that.
Yes, that would be great to show the capabilities. I think since it is a broad spectrum of people here, making this as some like workflow that like you guys are on this one. I have other ones here. Everybody in the group has some other thing. Al has like a trash robot that you can still speak to and does stuff back, so still could use this even though it's not mobile. But it's really that like workflow of how do I like collect the ROS bags or these chain of thought traces and like fine tune it and that whole thing. And we need to be able to show that. And that's what we're going through now. And like we do these tutorials in the AI lab. That's essentially what that process amounts to. So very, very exciting. This is great. You guys are like NASA JPL. So legit. This is crazy how far we've come with this this group and everything. So okay. That was awesome. I saw Cablan did rejoin. We obviously delved into this topic here. Thanks again, guys, for presenting that. That's super exciting. And like, for adopting, being early adopter of this, I realize like that's not easy sometimes because there's various factions within robotics, like traditional slam, and there's other some of these embodied guys, they don't like ROSA like at all. So we're like trying to like bring everybody together here a little bit if we could. Okay, so Chitoku, Cablan are both able to go if they want. Is your screen working again now? It still looks frozen. I'm sorry, Cablan. Okay. Next time.
I don't know. It's an issue.
Yeah, next time we can cover it. We can figure out your networking, and I'll run a test session for you.
So now is my screen
the
is
same. It's still the same. Sorry.
Otherwise, I will share from my mobile phone. So
we can cover it next time if we get your networking figured out. The articles are all on Medium, and it shows using those VLM nodes. Maybe the JPL guys will send the link to them, Cablan, if you want to drop it in the chat. Which is another Cablan, maybe you should try the ROSA agent and get that to run on Kaya if it's it's a memory limit. That's another challenge we're up against. Is like the memory on this stuff is a lot to optimize for the edge. But okay, given your AV problems, Chitoku, did you get the container running on your system that you were trying to earlier?
Yeah.
I wanted to quickly walk us through LeRobot, which is another kind of integration touch point for all of this. So yeah, it's good we're considering all of this at the same time.
Yeah, can you see my screen?
Yes, thank you.
All right. Yeah, so this is Hugging Face, LeRobot. Everybody's talking about, and then we talked about it earlier in this meeting. It's actually just a sort of framework for handling their proposed LeRobot dataset format, and it can support multiple policies. So I'm just going to show you what it is like to use this on JETSON. It's great. It now even runs on JETSON Orin Nano. So yeah, it is. I mean, this is even like being demonstrated with this low cost Kosh arm. So yeah, like everybody said, this is pretty low barrier of entry. I guess many people want to try this. So here we are. We thanks Dusty to even set up this page on JETSON AI Lab. So we have this tutorial. I'm going to just sort of like follow this tutorial to sort of demonstrate what it is like. We have already created the container. And it's already supported on the JETSON containers. So you can just set up JETSON containers on your JETSON and basically run this command on your JETSON. So what it is like is first I'd like to, so this is my JETSON AJX O-ring. It's running up and running healthy. And the way so the first example is just to visualize the data set. So for this, they are using Rerun IO. It's just a visualizer. What's nice about it is it runs on JETSON, and if you are using like mobile extern, like here, it supports X11 forwarding, window forwarding. So you can even like remotely see that. The way I'd like to do it is first launch readout. And this just being forwarded from my JETSON, but like showing up on my Windows. Because
Yeah, just a
mobile
web app.
extern come with X11 server, so you can take advantage of that.
I'm shocked you got the forwarding to work. That's
Yeah, it actually is pretty simple, straightforward.
It looks just like a web server though. It might be better to do it through the
Actually,
web.
people have been pointing that out. I suspect that's the case because this is supported on multi-platform, Linux, Mac. So you could actually just run it on your Windows machine, but I just chose to let it run on JETSON altogether. You can configure
Which is what we want to show. Yeah, because Remy Kadim, he has cool YouTube videos that he shows those Kosh arms folding his shirt, and he's going through it too, like trying to do these different robot learning algorithms and see what works and what not. And like they have a nice thing. It's kind of like the Hugging Face transformers, but for these robot learning policies. And they have like some diffusion stuff in there, and ACT, and like we showed the just basic commands to get you in that environment so you can start messing with it and try their different ones. And Nigel from the group has been using ACT. Al, yeah.
This screen, the visualize mode, I just got it working. This thing is so easy. I just went to the same web page. I typed this, and it showed up. So I was like,
and
I like stuff like that.
Hugging
so
Face
simple,
is easy.
You know?
Yes, yes, that's the whole point. Yeah, Hugging Face is nice, and what they've had to do is like port everybody's implementations to like transformers and standardize it, and so it's like nicely done. My fear is like the rate of these is coming out. Everybody's completely separate code bases. They're like sprawling, recreating the training results. It would be a nightmare, especially once you get like they're not doing it at like the VLA level or whatnot yet, but importing all those separate code bases for training, you would be better off just like making your own like VLA architecture than trying to recreate all that because it's there's so many things that need set to it. Sorry, go ahead, Chitoku.
So yeah. So I'm just going to demonstrate this first example of doing this. Let's see. Time is not working. Right. The way I set it up is like this. But essentially, if you like install JSON containers on your system, the one that is demonstrated on the tutorial would work. But I'm gonna just stick with my version. It's going to just like start everything, and it would pull up this one. Once it finishes downloading, here you go. Yeah, it's very short one, so it just like went through. But yeah, that's how it's being demonstrated. I think I closed one of the window, but yeah, there is all
on the page. I put a link to their
right.
account. That there's like 200 of these in there. Some are like way more advanced. This is just to prove that it like works on your system.
Right,
And,
you
like,
can change all the other, like
kind of like reinforcement
TOTO.
learning level. Yeah, I think there's kind of like a couple communities coming together here. One is more like smaller reinforcement learning policy kind of guys that if they have any visual input at all, it's like very low resolution, which is why you see a lot of these robot data sets like OpenX embodiment have like 128 by 128 resolution, or like not really usable for the larger CNN or transformer based methods that we're getting into now. And then on the other side, you have like the LLM guys and other like traditional robotics guys coming together and arrive like in hybrid solutions like this that combine it all, which is why we're also trying to go out and try everything and see how it all runs.
Yeah, I just need to change the path. But yeah, the point is it is already sort of set up. It is already set up. Everything is working on JETSON, so nothing more is needed. And then my plan is to, like I sort of set it up. Everybody also wants to try with a real robot, and here we are, $600 robot follower and leader.
You got
This is
one.
leader. Leader robot arm. So the idea is I'm going to like set up almost identical robot on the side. This is going to be a leader robot that I'm going to use to teach the follower robot to like actually, do the task, and I get to decode this and then put it into this framework to train, evaluate. So like Dusty was sort of like mentioning, hinting, it would be cool if we can come up with like really entry level robot policy-based imitation learning, kit or notebook.
I think you can do it with ACT. You showed that it works there. Let's see. I zoomed in on your
ACT is
thing.
ACT
it looks like it's running.
Supported.
Oh, the first epic always takes way longer. Okay, it's going.
But
How much memory
with the GPU? Only like I only shared 4 GB of shared memory, and that's probably as much as it's needed.
Yeah.
So like that,
You said it worked on Ora Nano, right?
Yes, it totally works on Ora Nano. This is JAO 32 GB.
What did it use, like a 16 gig swap file or something? Or it's amazing how it can do that. But
like it shows only like as a system, total system is only using 3.6 GB. So you don't need to probably worry too much about it.
You're right, because all the everything else is CPU like data set stuff that can get paged out, and that is something that occurred to me too. Like when going through this with VLA and VLM, is those are all written for like multi GPU systems where there is memory transfers. PyTorch and stuff does not do the zero copy CUDA managed memory that there are extra mem copies on JETSON in these pipelines and memory allocations that, like, when we select one of these or a few of them, down select them, we could do a more optimized training routine, or like loads way less memory because there's not multiple copies floating around. And what that translates to is being able to do on-device in situ learning like you're trying to show here.
Right. LeRobot people demonstrate this running on any computer, even MacBook. But yeah, certainly we can do this on JETSON. So
I forget which
with
policy.
ROBOT.
Yeah, I forget which policy that was, but I think ACT, it might have been that, and that seems a thing people are having success with, and it seems to work quite well for one task or small, very similarly related tasks, and you could have like a ROSA agent on top that selects which of those models to use and is not nearly computationally intensive as like the full-on VLMs. We're talking like a 100 million parameter VIT as opposed to like a multi-billion parameter VLM or VLA. So, and that's kind of what we're all working through and trying these all to understand the trade-offs between them, their strengths, weaknesses, capabilities, what kind of infrastructure you need to train and collect all the data for them. So this is really great that we like get us started in this. We can all like start messing with this now.
Just want to quickly like check with everybody. Like, are there anybody? Well, like how much of the people? How many people interested in like really, testing out with a real robot or like building this kind of local stuff? Oh, I see. Oh, cool. Yeah, if people can like raise a hand or. Oh yeah. People are interested in. Great. Oh yeah, you have, of course. You already, testing, right? I got those kids over this weekend and I started building. It's pretty straightforward. I would say this is a good entry place. But if you already have a robot arm that can even do the copy motion stuff, you can do that probably. I just wanted to mention.
Most of the cost is that you're showing that picture of the box, and those are all like Dynamixel servos. And most of the cost of this kit is just those servos, and probably like 90% of it or something. But they're really good, actually. Yeah, it might look like it's just a 3D print. Yours one looked actually more attractive than that one, but it does act. Unfortunately, that's about the cheapest that you can go for these type of systems today, and it is a great. That's awesome what they've done, because the Aloha system that ACT and others are derived from, it's a dual like teleoperated dual arm system. Those are like $25K, and that's like pretty normal. And that was also considered a bargain at the time too. So
it's still called low cost Aloha.
Yeah, it's continually going down, and we're trying our best to do that. Ergen had a question to ask. Yeah.
Hi, Ergen.
You're still on mute if you're. Okay, it sounds like they're having some trouble with their mic. I don't know. You can text it in the chat. Yeah, your sampling rate was off. I've heard that before.
It sounded like a chipmunk.
Yes. Yeah. Okay.
We can try hard to like processing our brain to like slow it down.
Yeah.
Maybe we need Whisper for that.
No, that's funny. So, and like Chitoku, you've been like networking with these guys, and that's another good for us to gauge.
Yeah,
like,
they're ROBOT as a manufacturer of the dynamic cell motors in the world, and they apparently is getting a lot of requests. So like everywhere you go, those dynamic cell motors are sold out, and they're sort of like back tracked for 2-3 weeks. So it's a little difficult. The trick I did was but like they're interested in putting this kind of kit together, and I make it available for people. It's even like listed on the website. So this is coming really affordable and accessible. I want to see many people testing this.
Hook it up hook it up to the ACT and just go through the normal thing and see if you can get it to work.
I will update on our website and with people in this meeting.
We'll continue amending that tutorial from Is the IO on this compatible with over Nano? Does it hook into the
totally just over USB. So
easy.
No problem.
Figures. Awesome. Okay. Then that's pretty straightforward and easy. And if somebody's starting completely fresh, that is, I believe, the lowest cost viable solution for doing like transformer-based robot learning with like the EDU discount for the Orin Nano at $299. I think these are around 200 each, and you need both. You need the leader and the follower. If you go to order this, you need both of those parts. So roughly like $600 to get started with manipulation. And are these 6 degree of freedom, Chitoku?
There are 6 motors, yes.
Yeah, okay.
But
well, there you go. All right.
With an arm and the effector, so like 5 plus 1, I guess, technically.
Okay, yes. Great. And like I have a 5 degree of freedom one here, and like that's fine. It's like scale things back. And Al, you want to go, man?
Chitoku, do you have like an email or something? I sent you a connection request over LinkedIn, but it's pending for a long time.
Oh,
and,
sorry. I
want to try.
I'm happy to
I'm trying this stuff. I have an OGX here on Orin, and I'm trying, and of course, nothing is working. So if I could bug you to help me with this thing, because I really want to get to know this stuff. So
sure. Yeah, I'm happy to help. Yeah.
Do you have like an email that you can share here or something?
Oh, I'm gonna just type my corporate email address here then.
Yeah, exactly.
This is my NVIDIA email address. You can contact me. You can contact me over LinkedIn. I try my best to like check my LinkedIn. Yeah, and I will accept your.
I think you're on GitHub more. Yeah, ping him on a GitHub issue, Al.
That's how
I think his email
Johnny sort of.
Yeah, no, it's great. And like Chitoku did the JetBot like hardware design and stuff. So it's great that you are doing this again, and will work with. And you'd also gotten all those partners to make the JetBots, which you now see on Amazon and WaveShare, and you like meticulously went through all of them and like checked it. So thanks for wanting to take this on, because then everybody that wants to get into physical AI, embodiment, etc., will do that. And we will do similar thing with JetBot, all this stuff for the UGV side of things. We'll be able to put that on there just as easily, and Kabalan had put it on his through Isaac Sim as well. So, okay. With that, we'll try to wrap things up today. Johnny, I know we want to recap a little bit what we're heading to next. Just before the meeting, I was trying to get CrossFormer. It built. Finally getting the tests all passing, but I presume we'll be able to get that working soon. Then the 3D diffusion policy. Chitoku's going to do the end-to-end testing of the robot arm with LeRobot Hugging Face. The gap that I see there is they don't yet have the higher end or newer policies, whatnot, in that. I'm sure they will get newer ones added in, or we can help contribute those. That would be great. So, was there any other questions or things people want to discuss? Al, I know you had mentioned some.
I need to share this Gaia robot.
Great. Okay. Yes. There you go.
Yeah, so using a JETSON Orion, I replaced from the Nano 2 Orion, and the Sim2 Real is already finishing. Isaac Sim2 Real. So by next week, we are conducting the robotics competition. Robotics event in our Bangalore NVIDIA office. So this is a base one using a dynamic serial motor.
Nice.
And
that's the
hardware,
right? Yeah.
Hardware and looping. Sim2 Real. What are the things happening on the hardware that will be replicated in the simulation in Isaac Sim? So that's finished, and so then I implemented the image processing from Isaac ROS, DNA inference for segmentation process. So like I already shared that blog in my Medium. Like if the people stand.
I just dropped the link in the chat again. People can go in there, and next time you can come share your findings from the AI summit and everything that happened. There's just been a huge amount of activity in like this area. So thanks for taking a huge part in it all and getting everybody started with this. It is interesting now that like all this is going in motion. We just talked with the NASA JPL lab about things. Where I see like you fitting in, like Chitoku is working on these robotic arm kit. You have like the Kaya UGV, aka JetBot. I just use that as a proxy term for any of these low-cost UGVs. It could also be like an iRobot Create 3, which has similar ROS interface that Spot has because it's made by like similar company with ROS support to it. So it can be dropped into whatever, and you can try some of the other more UGV oriented models, or do instead of, it seems most people are doing like the manipulation thing with it, but you can dial back the degrees of freedom and probably even more easily do a ground navigation one, you know, and scale up to the point where you're fine tuning a VLM to do it and given other directions or things like that, which would be really cool to see. And if you can put like the Orin NX 16 gigabyte on your JetBot or Nanosaur, like Raphael has the Nanosaur, that would be another good platform for these. Then you can have basically all the models that you want on there for ASR and TTS and all that stuff. So, okay, we're around like 10 past the minute. Johnny, any closing thoughts first? You've been driving a lot of these awesome expansion that we've had into like neural reconstruction, scanning. All of that is like coming around to all be like fused together in all this, and it's great to see. Hopefully over the coming days we can get a better handle on some of these other policies that we're trying to run here and what the performance is, how much memory they take, and being able to actually go off and train those. I think mostly it's all about like an intuitive workflow that even an end user could do. You know, there should just be like a button on the thing, you press it, start teleoperating it, hit it when it's done, and then like it saves that, and at some idle time it goes off and like trains those into it, and over time you just should be teleoperating it less and less until it like masters that skill or whatnot. And that's contrary to like, okay, I'm going to go record my ROS bag and like copy that over to my cloud system and like train this model and take it back. And so just kind of smoothing out that workflow helps everybody iterate much faster on these things. I don't know if anybody has any thoughts how that fits into the projects they're working on, or like, Al, you have the smart trash system. It's like a little different, but also the same. And like, how do these things overlap?
Remember I mentioned yesterday that I had this idea that I wanted you to share.
Yes.
And
I wanted to make sure you could talk about that.
Yeah, okay. I thought that the main problem today with robots is basically battery time. I mean, and the problem is that you spend a lot of battery, a lot of power, not moving them, but just keeping them still, because you have to many times feed with energy the servers just to do nothing basically. And then and then I thought of how Boston Dynamics used to use pistons, remember, instead of motors. And then
it was hydraulic. It had huge, and some of the humanoids you see, they do have power tethers, and it's realistic. The battery tech is one of the other contributing drivers to all of this, and like, it will all come together with like solar and like all that, you know.
Problem is that whether it's motor or whether it's piston, you still have the problem of keeping the thing still. So with a piston, you still need some kind of valve or something to close it so the liquid will not come out of the piston. And then I thought about this crazy idea that I'd like to share. That I don't know if you guys know what bentonite is. Bentonite.
It's like a clay-like substance. You put it in the bottom of a pond you're trying to seal or something, right?
Actually, bentonite comes from Benton, which is like an area of the United States. It's a mineral that they mix with. You mix it with water, and then it's used by the oil industry to dig holes in the ground to grab oil because bentonite when mixed with water has a very unique thing. If you don't touch it, it becomes solid. So it's a liquid that if you don't touch it, poof, it solidifies. But if you touch it, it becomes liquid. There's a scientific name for that, okay, or whatever. And then, and so that's why actually they use it for making these holes to get oil from underground, because all you have to do is keep the hole filled with that liquid, and whenever the drill stops, the liquid solidifies and the hole does not just shut down. So I thought about, instead of using oil or whatever liquid they use in these hydraulic systems, they could use some kind of bentonite mixed with oil or whatever, or pure bentonite. So if you want to shut down the robot or an arm or something, as soon as you turn off the pump, the bentonite will solidify and the thing will stay. It will stick. And then I thought, okay, I'm going to try this new ChatGPT that everyone's talking about, that is so smart, etc. And I gave it this idea, and the first thing that it told me was, this is nonsense, because bentonite is going to ruin the pump, etc., because it's abrasive, yada, yada. And then when I told the reasoning for that, it actually said, hey, that's a good idea. So I was like, well,
I don't know. Yeah. There people say like product design for it. Maybe it's good for like UIs or stuff like that. But yeah,
that's the idea that I had. That overall, we need to implement new actuators, and then I don't like what the market offers. I think that they suck basically.
Or just think about things a little different. How they, like, you're talking about things of scale or things running off of hydraulics or whatnot, and large outdoor vehicles might not be completely transitioned over to EVs, whatnot. Like some of the semi-trucking is using it. A lot of the really larger tractors and other things they just don't have the power density and torque yet to do it. But,
you mentioned something useful. I mean, this stuff, you could, if it works, you could build gigantic robots.
Yeah, you could just have fleets of. Yeah, that's what I think. This ROSA agent, like, you just make smaller EV solar self-rechargeable ones that don't need done lickety split, and let them go off, do their thing, stop for a charge when they need to, and add more if you need more turnover or like capability in there. And it would seem like you need to scale back the size a little bit to do like what you're saying, and have them like be off grid or not constantly need recharged. Otherwise, like a 48 hour battery life would seem like standard. Really good.
If you're able to just get batteries that last 8 hours, you don't need to change all the. Just get a better battery. Yeah, I agree with you.
Yeah. I've been looking to do like a lot of smaller EVs that are like side by sides or quads, mini skid steers, things like that I could use to like try all this stuff on around here, which should be fun. But for now, like as I mentioned earlier, trying to get back into like the physical side of robots to collect all the data and everything, we're still getting all the policies and understanding all of that. So I feel like not until that is done will I finally be able to get back into that. And so, yeah, I think for next time, my goals are to get the crossformer and the 3D diffusion running well and understand them, Chitoku with ACT and those robot arms. So, Johnny, we'll keep at it. Thanks for everything the past few weeks and all the contributions. The JETSON AI lab has grown so much that we need to like reorganize all the contents and everything. It's quite crazy. Thank you. But like everything we do and like set this up, it like allows us to keep up with near state of the art things at the edge, which like nobody else is able to do, and it is like not easy to compile these huge stacks on ARM. So thank you, Johnny, for doing that and like staring at the builds for hours and hours. So.
Now I'm trying to come back TensorFlow to no depends from Jetpack. So
okay, he's trying to build the whole TensorFlow stack completely from source. I'm like, Johnny, it's going away. We're like doing JAX, but like just I understand you like want. It's almost like we're like the Gen 2. Because everything needs built completely from source. So like our Gen AI stack right now for JAX, it's on CUDA 12.6, cuDNN 9.4. It's like bleeding edge of like of everything.
Yeah.
It's hilarious because like we're like JETSON AI lab here. And all right, with that, we're at 20 past the hour. Thanks guys for the great discussion on here. And I think this meeting has really helped everybody kind of like head in similar directions, because otherwise it's way too much for anybody to be able to do alone. And like we will be getting out there and using this stuff for like practical applications and sharing that with everybody else, and they can go do the same. So thank you guys as always. The next meeting will be in another 2 weeks on October 1st. So yeah, we're working right into this here. So all right, thank you guys so much. Thanks, Johnny, Al, Chitoku, everybody. Keep in touch, and we'll see you next time. Have a great afternoon.
See you next time, guys. Take care.
Bye.